Okay, so for 9.1, you guys talk about inverse and direct relationships. So if we kind of define what they are first, so if something is inversely related, or it has an inverse relationship, what that means is as one goes up, the other one goes down. So let's say as an example, we could use exercising. So the more that we exercise, the amount of fat that someone may have is going to decrease. So they go in opposite directions. Same thing may be true if, like with spending money. The more that we spend money, the less we'll have in the bank account. So our bank balance would decrease. So that would be like an example of something that's inversely related if you had to give an example. And then the other type of relationship you guys talk about in 9.1 are things that are directly related. So when things are directly related, they follow the same trend. So an example could be, let's say, the more time that you study for a quiz, so time spent studying, the higher your grade. Or as an example going the other way, so in this case we saw that as both of them, as one increases, the other one also increases. So let's say as another example for direct relationships, let's say that as the time spent working, so let's say hours per week worked or hours worked. So if you decrease the hours that you work per week, you should expect that your paycheck would decrease. So the amount of money you make would decrease. So direct relationships is whatever, as one increases, the other one also increases. Or as one decreases, the other one also decreases. If we were to show that using a graph, so we kind of did it with these real world examples, but let's look at what they would look like in a graph format. If something is inversely related, the graph would look like this. Okay, you would have a negative slope. So as one increases, so as this x gets bigger and bigger and bigger, the y is actually getting smaller. So if I throw in some tick marks so we can kind of illustrate this point a little clearer. Let's say this is 10, 20, 30, 40, all the way up to 70. And let's say this is 10, 20, 30, up to 50. So as we would see, if we're looking at, let's say, this value here, when x is 10, the y is 50. And let's compare that when we have a higher x value. So when x is 40, y is 30. So what we can see is as the x gets bigger, 10 to 40, the y is getting smaller, 50 to 30. So that would be how we could look at it in a graphical representation. Let's look at it for something that's directly related. It would look actually like this. It's going to have a positive slope. Let me throw in some numbers across here. And some numbers up here. Okay. So we kind of illustrate that point. Let's look at what happens when x is 20. So when x is 20, y is also 20. And let's see what happens when x is 100. So when x is 100, we go over, y is like 110. Okay. So what we notice is as x gets bigger from 20 to 100, the y is also getting bigger from 20 to 110. So that would be how we would look at it if we have a graphical representation of inversely related versus directly related. Now let's look at how you would do it in an equation format. Okay. So if we say that something varies inversely or varies directly, so I'll use the term varies inversely, which is what they probably use in your textbook, versus varies directly. We have a set of equations, and I'll write two sets of equations for each of these scenarios, and then we'll go through how we would apply those. So if we're dealing with something that's varying inversely, it's always a variable, and I'll put y, but it could be any variable, is k, which is a constant number. K is just some number, over x. So if we're varying inversely, we're going to follow the general equation y equals k over x. If something is varying directly, it's going to be y, and again, this y doesn't have to be y, it can be whatever variable they tell you to use, equals k times x. Again, that k is a constant number. Okay, another way that we could write this equation is we could simplify it a little bit or rearrange it. And so I'll show you that as well. So we could, for this varies inversely, we could, if we want to just get the x's and the y's on the same side, we could multiply both sides by x. So another variation of inverse equation would be x times y equals k. Okay, so both of these equals y equals k over x is an example of an equation that would be inversely related. Same is true for x times y equals k. Let's do the same thing over here. We just want to get x and y on the same side. We would go in and divide both sides by x. So we get y over x equals k. Okay? And so we'll use this equation and this equation to help us predict things that may be inversely related, and we can use these two to help us predict things that may be directly related. Okay, so let's talk about when we would use each of these equations. Let's look at a few examples. So let me rewrite this up here so we can kind of keep track. Okay. Okay, so let's say that you're given a couple different examples in equation forms and you're asked to figure out whether it is inverse, direct, or neither is also an option. So let's say you're given the equation 3y equals x, or x over 4 equals y, and let's say you have x plus 3 equals, let's say you have y plus 3. Y plus 3 equals x. And so the directions are to figure out, just by looking at the equation, whether we're dealing with something that's inversely related or directly related. So to tackle this, if you have it in the equation form, so again, we're having this in the equation form, you want to solve for y. And that way, when we solve for y, we're going to then go back and compare it to each of these equations to see which type we have. Okay, so for this first one, if we want to solve for y, I'm going to rewrite it here, we would divide both sides by 3. Okay? So we would get y equals x over 3. Okay? Or we could write that as y equals 1/3 x. So now if we go back up to the top and try to compare it, what type of equation do we have? We have y equals some number times x. Well, for inverse, it's y equals k divided by x. Well, x is not in the denominator for this example. So we actually going to have a direct relationship. It's y equals some number times x, which is what we have. Y equals some number times x. So this would be directly related. Okay, varies directly. All right, let's look at this one. So we already have it in y equals format. So y equals x over 4. We could actually write that as y equals 1/4 over x. The key with this is the x is not in the denominator. So again, this is another direct relationship, varies directly. Okay, let's look at this over here. Well, we have to get it into y equals first. It's y plus 3 right now, so we're going to subtract 3. So we get y equals x minus 3. Well, neither of our equations deal with plus or minuses in our equations, so this would be an example of a neither. Okay, so again, for something that vary inversely, x should be in the denominator. For something to vary directly, x needs to be multiplied by some number. So let's look at one that may be an example for inverse. So what would an inverse relationship look like? Because we did two direct relationships. We would have something like, let's say we have 2xy equals 4. Okay. Well, we want to get it into y equals. So we're going to just divide both sides by 2x. We just want the y by itself on the left. So we would get y equals 4 over 2x. Well, the 4 and the 2 we can simplify even further to just give us y equals 2 divided by x. Okay? So now we see x is in the denominator of the fraction. That's going to be an example of inverse relationship. So this 2xy equals 4, this is inversely related. So this is how we would tackle these types of problems. If you're given the equation and you're asked to figure out whether it's inverse or direct, you want to solve for y and then go back and kind of match it up and see which type you have. Okay? They could ask you to figure out inverse and direct relationships using tables as well, which I think you may have had for your homework for 9.1 in the textbook. Okay? So if we are dealing with tables, we have things in table form. We want to use this equation and this equation. Okay, that's going to be the most helpful for us if we have something in table form. So let's look at two examples. Let's say we have a table that's this. So in this case, we have tables. We want to look at the values. I would encourage not to just try to see if this increases and that decreases, that it's inversely related. Let's instead try to use these equations, just because your teacher may use numbers that may not work out for you to do a little trick to see, well, if this one's getting bigger, that one's getting smaller, it's inversely related. So it's best to just try to use these equations when we have tables. So what we want to do when we get things that are in the table format, we want to look at the pairs or the coordinate pairs. And we want to do two things. We want to multiply the x and the y's together and see if we get the same number each time. And we want to divide the y divided by the x each time to see if we get the same number. Okay, so I'm going to do 2 times 18. I'm just doing the x times the y. And then I'm going to do 3 times 12, again, the x times the y. And then we're going to do 4 times 9, which is the x times the y. And what we're looking for is we're hoping that we get the same number each time. If when we multiply them together, the x and the y, and we get the same number each time, then we're dealing with an inverse relationship. Okay? So I'm just going to test it out to see if that's the case when we multiply them together, if we get the same number. So 2 times 18, that's 36. 3 times 12, that's also 36. 4 times 9, that's also 36. 6 times 6 is 36. 12 times 3 is 36. Now be sure to test all of them in the table. It's not uncommon for teachers to have all of these work and then the last set doesn't work. If you were to have all of these equal 36, but then this last one wouldn't work, we would have to say it's neither. You have to get the same number each time when you multiply in order for us to say that this is inversely related. Okay. So just to kind of recap, if we're given a table and we have to figure out whether it's inverse or direct, you want to use these equations. Okay, we multiply x and the y's together and we got the same number each time, so it's going to be inversely related. Let's do an example of what direct would look like in a table. So let's say this is what we have here. Now, let's try it both ways. So if we were to multiply, we want to see if we multiply x and y each time, do we get the same number? So 1 times 4 is 4, 2 times 8 is 16. Oh, we're not getting the same number. 4 times 16 is 64. So when we're multiplying top and bottom, x times y, we're getting different numbers. So it's not going to be inversely related. So let's test it to see if it's directly related. So for direct relationship, it's almost like the slope. We're doing y divided by x. So we're trying to see if when we do y divided by x, do we get the same number each time? So I'm going to set up those points. So we would want to see, okay, when we do 4 divided by 1, so y divided by x, and we do 8 divided by 2, so y divided by x, 16 divided by 4, 24 divided by 6, 32 divided by 8, and 40 divided by 10. What we're hoping for is when we do y divided by x, if we get the same number each time, then that means we're dealing with a direct relationship. Okay, so 4 divided by 1 is 4, 16 divided by 4 is also 4, 32 divided by 8 is 4, 8 divided by 2 is 4, 24 divided by 6 is 4, and 40 divided by 10 is also 4. So we do, when we divide y divided by x, we get the same number each time. That would indicate that this is a direct relationship. So they're directly related. Okay? So again, just to kind of recap, for the table method, when we're using the tables, it's helpful to use these equations that go with inverse and direct. And what we're trying to compare with is if we were to multiply x times y, do we get the same number? If so, it's inversely related. If we have to divide y divided by x, if we get the same number each time, that means it's directly related. If on the flip side, we're given an equation, like we did a few minutes ago, then we want to use these guys to help us figure out whether it's inverse or direct. If in an equation format, once we get it into y equals, if x is in the bottom of a fraction, then that means it's inversely related. If we have an equation and we get it into y equals and some number is being multiplied by x, then it's going to be a direct relationship. Okay. The last two things for this particular unit is you may be given word problems. So there's two different types of word problems that we'll tackle with this section. Okay. And so for word problems, we'll go back to using these original equations for inverse and for direct. But you can be given different scenarios, like you might have something that says P varies inversely with Q. Okay, so now we're not dealing with X and Y's. Whatever variable is listed first in the sentence, that's going to be what's going to be on the far left. So varies, you can think of that as saying that's equivalent to like the equal sign. So this is saying P equals, it's inverse. So for inverse, we should be dealing with a fraction, K over Q. So you're always going to have a K in your equation. So this would just be P equals K over Q. And the Q goes on the bottom because it varies inversely. Let's say that you had S varies jointly with W and X. Okay, so joint is another word for direct. Joint we usually use when we're dealing with two different variables, or two. So instead of just having y and x, we have three variables, s, w, and x. So what this would mean, we said varies is like another kind of little hint to tell us that we need an equal sign. So this would be s equals k, because k is always in the equation. Now jointly is another word for direct, w times x. When things are directly related, they're multiplied by each other. So x equals k wx, or s equals k times w times x. Let's say you get something that's a little more complicated. Let's say we get a sentence that says C varies inversely with the square of D, but directly with the cube root of T. Okay, so there's a couple things that we want to point out. Be very careful when they say square versus cube root. If something says square, we want to do like x squared. We want the 2 to be as an exponent. If they say the square root, it has to be in a radical. If they say the cube of a number or the cube of a variable, it's going to be, the 3 is going to be as an exponent. But if they say cube root, we want to put that y or that variable inside of a radical with a 3 here. So just be careful with these terminologies. So we have C varies, we know that means equals, varies inversely with the square of D. Okay, well the square of D, that means it's D squared. Okay, and it varies directly with the cube root of T. So the cube root of T would just be the cube root like this with a radical. Okay, so we kind of have our variables. We have c, d squared, and the cube root of t. So if we tackle this, c varies inversely with the square root of d. Let's start with that part. So it's going to be c equals, it varies inversely, so k over, and it varies inversely with the square of d, so d squared would have to go on the bottom, okay? But it varies directly, and we know what, if something varies directly, it means we're multiplying them, not dividing. So it varies directly with the cube root of t. So that means the cube root of t gets to be up here being multiplied by the k. Okay, so that would be kind of a more complicated one where we have inverse and direct in the same one. So just to recap, if something is inversely related, that variable should be in the bottom of your fraction. If something is directly related, that variable should be multiplied by your k. K is always in the equation and k is always in the numerator if you have a fraction. Okay, so let's switch over to looking at how we would do word problems if you have it like actual word problems. So I'm just going to shift the camera a little bit. We have a word problem I already wrote out here. So one of the things with word problems is we have multiple steps that we have to do. And so the first step that we do for word problems, the first thing is we need an equation. Okay. The second thing we're going to do, we need to solve for k. Because when we write our equations, whether they're inverse or direct, we're going to have that k value, which is a constant number. So the second thing we need to do is solve for that k value. The third thing that we would need to do is actually answer the question. And so as we see, we can't really do a word problem unless we do these three steps. Okay, so if we go through this, I'll read it through once and then we'll go back and kind of highlight the important parts of what we were given. Okay. So the price, this is going to be one of our variables more than likely, the price of a concert ticket varies inversely with the square root of the distance. That's going to be important later. So the price of a concert ticket varies inversely with the square root of the distance from the stage. So if your friend buys a ticket for $20 and the ticket is 10 feet from the stage, how much would a ticket cost for the front row, which is 16 feet from the stage? All right, so if we tackle this first, number one, we have to come up with an equation. So it looks like we have price, let's call this P for our variable. And the other variable it says we have, it varies inversely with the square root of the distance. So that would be square root of D. Okay, so we got to put those together. P varies inversely with the square root of D. So that would be P equals K over the square root of D. Because remember, inverse means we need to have it in the denominator of a fraction. All right, so that's the first part. Got our equation done. Only issue is we don't know P, we don't know K, we don't know D. There's a lot of unknowns we don't know. So the first thing to try to get turn some of these variables into numbers, we need to solve for K. Well, that's why they give us this second sentence. And this will be true for all word problems. You'll get one sentence to help you come up with the equation and one sentence that has a bunch of numbers to help you solve for K. So if we have this sentence, your friend buys a ticket for $20, so that's giving us the price. So they spent $20 and their ticket is, this was 100, I accidentally erased it. So this was 100, but that is 100 feet from the stage. So that's telling us the distance. They're 100 away from the stage. Okay. Now that's giving us enough information for us to solve for K. Well, we know the square root of 100 is just 10. So we have 20 equals K over 10. And then we go ahead and multiply both sides by 10. So we get 200 equals K. Right. I believe this actually was 1,000 feet away. My mistake. So if we're 1,000 feet away, the square root of 1,000 is actually 100. So we are actually multiplying both sides by 100. So K is actually 20,000. So 20,000 equals K. So we've solved our second part. Okay. Now the reason why that's helpful is we can go back to our original equation and we can modify it a little bit. We can take off this K value and replace it with what we know. We know K is 20,000. Okay. All right, so I'm going to erase this work. And now we can actually answer the question. So the actual question is, How much would you pay for a front row ticket that is 16 feet away from the stage? So now we can actually answer the question. We don't know how much you would pay, but we do know that the ticket or that the seat is 16 feet away from the stage. So then in that case, we can do P equals 20,000 over 4, because the square root of 16 is 4. So then that means the price of that ticket is going to be like $5,000. So maybe this is like Beyonce or some really famous person. So that front row seat is really, really expensive. Okay, so just to kind of recap, the way that we solve this problem, I'll shift the camera just a little bit here, is that we want to first identify our variables so that we can write our equation. It was price varies inversely with the square root of D. So we use that information to figure out it was P equals K over square root of D. Then we want to take this second sentence that has a bunch of numbers in it to help us solve for K. So that way when we solve for K, we can replace that K value in our equation that we wrote in step 1. And then finally, the last thing we can do is actually answer the question. And we can do that by taking whatever number they give us, plug it into our equation with the K value that we found, and use that to solve for P. So hopefully that is helpful to review for section 9.1, which should be the only section on your quiz.